Welcome, my name is Dr. DrWedding, and this is DrWedding DC13. Silicon diodes in a series circuit. In this video, you will learn how a silicon diode works and how to solve a series circuit with a diode as one of the components. A diode can only be in one of two states. It can be passing current like a piece of wire and have no resistance, or it will be blocking the current like an open circuit and have infinite resistance. The schematic symbol is shown below. Each side of the diode has a name. One side is the anode and the other side is the cathode. On a real diode, the cathode is marked with a bar. The direction of current flow is from the anode to the cathode, and it is in the same direction as the arrowhead created by the schematic symbol. When current is flowing in this direction, the resistance of the diode is 0 ohms. A diode will block current flow from the cathode to the anode. Think of the bar on the cathode side of the arrowhead as a brick wall that stops current. In this state, the diode has infinite resistance. Not only does the diode need to be facing in the direction of conventional current flow, a diode also needs a minimum voltage across it to turn on. This minimum voltage is called the threshold voltage. If there is not enough voltage to turn on the diode, it will act like an open circuit. The threshold voltage is the toll you need to pay in order to let your current cross the diode. It is like a toll bridge or a toll road. If you want to cross a bridge and the toll is $5, the booth operator does not care if you have $10 in your pocket or $100 in your pocket. The only thing he cares about is getting his $5. If you give him the $5 toll, then you can pass with no resistance. If you do not have the $5 toll, you are blocked from passing. The diode does not want money from you. It wants a fixed voltage that it takes from the supply. Different types of diodes have different threshold voltages. For example, the standard threshold voltage of a germanium diode is about 0.3 volts, and the standard threshold voltage of a silicon diode is about 0.7 volts. When a diode is in the circuit, you need to pay the diode toll first. What is left over is shared with the resistors. For a series circuit with a diode in it, Ohm's law becomes the total voltage minus the threshold voltage of the diode equals the total current times the total resistance. If the total voltage minus the threshold voltage of the diode is less than or equal to 0, you do not have enough voltage to pay the toll. The diode will not turn on, and it will act like an open circuit. When you solve a series circuit with a diode in it, you always follow the same steps, and in the same order. These steps will help you determine if the diode is acting like a piece of wire or acting like an open circuit. First, make the table for the circuit and fill in the known information. Second, check if the diode is pointing in the direction of conventional current flow. If it is not, then it is reversed, and the diode is acting like an open circuit. You should be able to get the solution by following the same 4 rules covered in the video on opens and shorts. The current in the series circuit is 0. The voltage drop across each of the resistors is also 0. The voltage drop across the diode is equal to the supply voltage. The resistance of the diode and the total resistance are infinity ohms. Third, check if your supply voltage is larger than the diode's threshold voltage. If it is not, the diode is acting like an open circuit. You should be able to get the solution by following the same 4 rules. Fourth, if your diode is in the correct orientation, and there is enough voltage to overcome the threshold voltage, the diode is on and passing current. To get the solution for a diode in this state, follow these rules. The voltage across the diode is equal to the threshold voltage. The diode has a resistance of 0 ohms. Subtract the threshold voltage from the supply voltage. Solve the series circuit with the updated supply voltage as shown in the equation below. Here is the first silicon diode example. The silicon diode in this example has a threshold voltage of 0.7 volts. Step 1. Start with the table and fill in the known values. Step 2. Check if the diode is facing in the correct direction. In this example, the diode is not facing in the direction of conventional current flow. A reverse diode is an open circuit. This is just like the open circuits that were covered in the previous video. If a series circuit has an open, there is no current flowing. If the current is 0, then the resistors have a voltage drop of 0. The open caused by the diode will take 100% of the voltage. So, the gap caused by the diode will be equal to the supply voltage. Finally, the resistance of the open and the total resistance are both infinity ohms. Because the diode is not conducting, it is an open circuit. You may wish to pause the video and verify that the reverse diode example obeys the 4 rules that were discussed earlier. Here is the second example with a silicon diode. The silicon diode in this example has a threshold voltage of 0.7 volts. Step 1. Create a table for the circuit and fill in the known values. Step 2. Check if the diode is facing in the correct direction. In this example, the diode is facing in the direction of conventional current flow. If the diode was reversed, it would be an open as demonstrated in example 1. Step 3. Verify there is enough supply voltage to overcome the threshold voltage. In this example, the supply voltage minus the threshold voltage is negative. Because this value is negative, you do not have enough voltage to turn on the diode. This is like not having the money to pay the toll at the toll bridge. Therefore, the diode becomes an open circuit, just like the previous example. The diode is replaced with an open and the rules for an open are followed. In the previous example, all of the values were calculated. This time, we will blindly follow the rules and ignore the calculations. The current in the series circuit is 0. The voltage drop across each of the resistors is also 0. The voltage drop across the diode is equal to the supply voltage. The resistance of the diode and the total resistance are infinity ohms. In the second example, the diode was also acting like an open circuit because it did not have enough voltage to overcome the threshold voltage. No matter what the reason, the open circuit follows the same 4 rules. Here is the third silicon diode example. As before, the silicon diode in this circuit has a threshold voltage of 0.7 volts. Step 1. Create and fill in the table. Step 2. Check if the diode is facing in the correct direction. In this example, the diode is facing in the direction of conventional current flow, so it is not an open. Step 3. Verify there is enough supply voltage to overcome the threshold voltage toll. In this example, the value is positive. Because this value is positive, there is enough voltage to turn on the diode. The voltage drop across a conducting diode is equal to the threshold voltage of the diode. The resistance of a diode that is conducting is 0. Now you can solve the series circuit. Start by calculating the total resistance. Remove the threshold voltage from the total voltage. And calculate the total current using the equation below. Current is the same everywhere in a series circuit, even through the diode. Finally, Ohm's law will give you the voltage drops across R1 and R2. You can see the solution to this circuit obeys the rules for a diode that is on. You may wish to pause the video and verify the rules for yourself. As a review, you should also use the values that were calculated and verify Kirchhoff's voltage law for this circuit. This is the final silicon diode example. It follows the same steps as example 3. You may want to pause the video and see if you can solve it. When you restart the video, the solution will be given. Here is the solution to the fourth silicon diode problem. The diode is conducting, So the voltage drop across it is 0.7 volts and the resistance is 0. The supply voltage is reduced to 19.3 volts and the series circuit is solved using this new voltage. Example 3 and Example 4 are the same, except that the power supply voltage increased. Even though the supply voltage increased, the voltage drop across the diode remained the same in both examples because the voltage drop across a diode is constant. I hope this video helps you understand how a diode works and how it changes a series circuit. If you find these videos helpful, please like the video, leave a comment, and subscribe to my channel. This is the only way I can continue to make these videos.